Okay. It's been a little bit, but we are here. So let's get started. See where we were. Okay. Currently in the middle of updating the parser to take identifiers a little differently. I left mid-update. Parse expression leaf. Parse function call, is that where we're at? Yes. We are going to, where are we at here? Expected open parent after identifier. Right, so it thinks this is a function call. So it expects this to be an open parent, which is here, because function name, right? We're just grabbing the function name. So first of all, why does it think this is a function call? Because it hits this, probably. Let's go back down here. Let's actually just go straight into debugger time. I also just realized I did not make this bigger. That's what I get for not streaming for a while. Okay. Parse expression leaf. We are not here. Where's the parser? Okay. Expression leaf. We are here. Okay. Next is identifier right. Okay. So we should just see this immediately. No, this should be a function call. Because what is after next? So this is already wrong. When we see right, what is known type doing? Fundamental, any of, prefixed any, or seen this type. Okay. So that's obviously failing. So then we're down here. Right, we're missing this open parent for some reason. So let's just go there. Let's back it up. Back it up to here. Next is right. token is name. And then after next. Oh, we skipped past it. It's now 2, that's why. We skipped past one extra one. Should not be doing that. So this should be we can't do it like this. We need to do just trying to take a shortcut there. There. Hey, look at that. I think we're working now. What do you know? So next is right. After next should be the parent open. We see it. We parse a function call. Great. Come back through here. Now we're on the std right here. So now, am I not centered? All right, I need to stop looking at my preview. Now we should see this whole thing, and it's not a known type. What is the after next offset? It's just 1. Which shouldn't be actually, because we should be going here until we no longer see an identifier. Right? So let me go back up here. This is for next. Or for right. So we skip past it. Now we're on std. So token is name. It should be, right? Because it is oh, I guess I can't see what it is, but that's okay. It should be this, which should be a name, and it's not. What is token is name doing? Token identifier, pre-proc identifier, or fundamental type. Right. A name is now also a token concat, which we added before. That's also a name. Token is, wait. What did I do? Oh, how did I do that? Oops, okay. Let's go back to this. Add this back. Should probably make this bigger too, huh? Okay. Let's go back to this. Skip this. Okay. Token is name. It should be, which it is. Should be again, which it's not. So we should see name, name, name. There should be 3 names there. And you know what? Let's do this. Just so we can debug this a little easier. We will call this let's do this. Hello, hi. How y'all doing? Do after next. And we'll just keep updating this here. Yeah. Okay, now let's see where this puts us. So, next is the std. After next should be the concatenation. Skip past it. Now after next is the parent open. Oh. Right. That's the concatenation token. The parent is then its own singular token. Right. So, yes, that's why. So, okay. That's fine. Does your parser support reading inputs from standard in? No, right now, I guess I could make that work, but no, right now it, you pass it a starting file, and then, based on these depend directives, it tells it where the other things to look for are. Or if you're including things, it will work its way up the, like the include hierarchy and parse all those things. Although I guess technically the parser doesn't actually care about files. The parser itself just cares, you just pass it a string of your text. So really, I think. Yeah, it just wants you to parse a lexer, and the lexer doesn't take a file. It just takes the source code. So yeah, you could very easily just call those two functions from standard in, and it would do the same thing. So, okay. So is there a reason that I did that way? I think it was to make the lexer have to care about less. Oh, actually, no, this is actually easy. If we come across, yeah, if the token is a concatenation, safe skip concat. We'll just do that. We'll have a function here called safe skip concat. This is not a node, this is the parser. Do you lex as you parse or pre-lex beforehand into a buffer? I am pre-lexing, and the way it actually works is I actually have a bunch of different lexers. Like technically there's a lexer per file, and then the parser here just takes a pointer to the current lexer as it's going through. So it's all lexed up front, and then the parser eats through each lexer as it goes through. So when it grabs the next lexer, it sets the token cursor back to 0 to start back over on that lexer and works its way through. I do enough stuff where I want to peek ahead into the lexer, which is maybe bad practice, I don't know. I do it enough though that I want to just have the lexed tokens as a big array and just be able to move around in it kind of freely. So that's kind of why that's like that. Okay, so safe skip concat. We're gonna say, we'll say safeskit concat tokens. And this is gonna say expect so expect, we're gonna say expect token parser. Let's grab the current, I guess. The type, we're expecting a concat, and we should pass the context on through too. Okay, error context. How do you handle left in templates as a shift left? So I don't really use templates, I don't use templates, and technically this started out as just a C parser, not C++. So I actually just didn't handle those at all. And now this has kind of morphed into more than just a C parser. It's kind of my own little mini language. So I just don't handle those at all. But in any of those ambiguous cases where, for example, those might be templates or not, that's where I would use look ahead in the lexer. So the lexer will just lazily eat everything as tokens, and then it's the parser's job to try to figure out what that thing is. So in that case, I would look ahead when I see the less than. And actually, let me look in my current lexer, because I don't parse C++. Let me see if I have... Yeah, so because I don't parse C++, I actually, if I see two less thans next to each other, the lexer assumes it's a shift left. So if I were doing this with C++ in mind, I would have to stop at less than, and the lexer would just have to eat them individually and let the parser figure it out. So is this live or recorded? This is live. I'm live right now. Your caret movement is really quick. Are the key bindings of 4coder anywhere near the defaults of Vim or Emacs, or is it made up yours and muscle trained? So I actually started using Emacs. That's what I have the most experience in. Actually, at this point, probably 4coder is equal to it. But when I was doing Emacs, I did not use the Emacs or the Vim key bindings. I am totally just on, even in Emacs, I use the arrow keys to move the cursor around. But one thing I got from Emacs, and that 4coder does also, if I hold control when I'm doing it, it just moves to the next blank line. So that's how I get around really fast. And it ended up my coding style ends up having these like logical kind of new line empty spaces in certain places, which that's definitely muscle memory, and it helps me move around. And if I need to move around faster, I'll either page up and page down, or I'll just search for the, like if I want to go to parse expression leaf, I'll just search for it and it'll get me there. So all the navigation is pretty much arrow keys and holding control. So we expect a concat token, and then we can advance, or wait, we're not skipping them here. We are just counting them. So maybe this doesn't need to be a function. Let's not make this a function yet. Let's just do this in here. Okay, so we can do this. Or no, we can do this. We can safely just do this again. So expect, dude, what is going on with me tonight? Is my keyboard in the wrong place? Parser, next. Well, you know what? All we're doing is skipping ahead here. No, I should be doing error checking here. I should not be lazy. Type, okay. So after the concat, we expect a token open paren. And then we skip again. We expect, no, this really does need to be man, this is kind of gross because all we're doing is looking ahead here. We're not actually wanting to skip the parser forward. Okay, I think this will be a utility function for safe peek ahead and verify concat tokens. How about that? Let's be very verbose about what's happening here. We will say we'll take the offset as a variable. Let's just do this. So we are going to look ahead by offset, and so we can remove that. We can look at offset should be a concat token. Then we can just do this, but we will skip it ahead. Then this needs to actually be assert. Well, this can't be an assert. We need this to be a if not token is name is what this needs to be. After next. So if this is not a name, because we want this to be recursive, it's not always going to be a concat if we call it a second time. So this will be a parse error. Parser f this will be next. And you know what? We do want the current one, because for good error messages, we want the current token that you're on. Current token, error context, expected identifier, got, you know what, we will do this, we will just make this message, Okay. Expect identifier, and we got a what did we call this? Lexer token type strings of next. Okay. That's fine. Then the next we expect a token parent open. Then we expect no, we only expect this if next type is a concat. It's the only time we expect this. And then we can peek ahead and verify again. Yeah, because if this isn't even a concatenation, we don't even have to worry about this. Hello. How are you doing? Nice to meet you. Had you started out on Tilde Club with your personal page? I'm not sure what you mean by that. I don't know what Tilde Club is, so the answer is no to that question. But then also, what personal page are you talking about? I'm curious what you're talking about. Yeah, if this isn't a concat token, we don't have to do anything except skip it. So otherwise, we can just skip it. But if it is a concat, we expect there to be a parent open. And we skip it. And then we can recall this. Offset current. No, this will be next and error context. What am I working on? I am currently working on, broadly speaking, I'm working on a metaprogramming system for, it started out built in C, but the thing I'm currently doing is right now, the metaprogramming language stuff. I'm trying to get this concat syntax to work. I've basically like replaced macros with these things called snippets, which are basically macros, but they are parsed. They're not just a textual replacement, they're actually parsed and stuck into the syntax tree wherever you call them. But because I'm not using macros, I'm missing some functionality, one of which is this concatenation syntax to concat stuff together for names. And currently, the representation for identifiers in the tree is just a single string, which isn't going to work when I'm trying to support this concatenation stuff. So currently ripping that stuff out in the parser to make it more robust and upgrading it to support these things. The one linked in your about section, it just has the feel. Oh, like my website. Yeah, and my website's actually going to get overhauled at some point. But yes, that aesthetic is both my website, it's my editor. If you look over here at my terminal, like my tmugs, it's all that stuff pretty much looks the same. So I was inspired mostly originally by Handmade Hero, if you know what that is. And that kind of evolved into a slightly different style that now I kind of use for everything. And yeah, no worries, you're not interrupting. I like the fact that people watch and ask questions and talk, so Let's just see where this is at. This is no longer called that. This is this, and we pass it the parser, the offset, the current token, which is after next, and the context. I don't think any of that is right, but we will see. Right, this needs to be next type. Ah, what is wrong with my fingers tonight? Okay, let's see where that puts us, because I honestly have no idea at this point. Let's go up here. So this should be right. Yep, so skip ahead. Now we're on STD, so we are right here. We're parsing this. So it's not a literal, it's not a keyword, it is a name. So our after next offset is 1. And after next should be the open paren, or the concat node, which it is. So because it's a concat node, we're going to peek ahead and verify the concat tokens. So next is the concat token. If it's not a name, we error, but it is a name. So concat, we peek to the next one, which is the paren open, which we expect it to be. So we're good. Wait. Oh. Expect token. Does that occur? Oh, I can't do expect token. Expect token is expecting a parser. Okay. You know what? This is a dumb way to do this. Let's just make a copy of the parser. We've done this little trick before. We're gonna say peek ahead parser is parser, and this will make our lives way easier. So you know what, let's undo this whole function, because this will make it a lot easier. So given that we have a parser, now we can just skip ahead. We don't have to do this weird peeking forward thing, which will make our lives a lot easier here. So if the next thing is, we basically now want to skip ahead until we no longer hit an identifier. So while we're gonna say peek next is peek token peek ahead parser, while peek next, or while token is name peek next, yeah, we're just gonna advance the peek ahead parser, and we're going to set this again. So this should put us back to where we were. And this should be peek next. This should be peek next. Yes, okay. Okay, so this is the same place we were in before, only now we should be a lot cleaner. We're not having to like keep track of offsets and do all this stuff. So peek next is right, we'll skip ahead. Peek next is std, skip, skip. Peek next is concat, skip, skip. Peek next is open paren. Great. So Now this thing can be so this thing can be if peek next type is a concat node, do one thing, otherwise we'll just do this other thing. We will say, now we can call this skip concat tokens. And we'll use it on the peek ahead parser. Do you think while is decomposed in if do while automatically and I mess with the optimizer, or is it a thing in C2? Can you rephrase what you're asking? Do you think while is decomposed in if do while automatically and I mess with the optimizer, or is it a thing in C2? When you say you mess with the optimizer, you mean by something you're doing? Can you elaborate on what you're asking? And I'll try to answer. So skip concat tokens. And this is nice because we can just pass the whole parser in and an error context. And we'll put this note back in. In assembly, this is done to have one just as it goes. Oh, yeah. So are you asking if you should decompose the while loop yourself? If that's what you're asking, you really shouldn't have to. The C compiler at this point is pretty intelligent and can do that stuff for you and probably will. Yeah, I don't think it would be considered harmful, but you definitely should not have to worry about doing that yourself. Unless you're in like crazy deep optimization land and you are looking at the disassembly and you see a piece of code that it's doing the wrong thing in that case, I would definitely recommend you... That's a very case-by-case basis thing. You would just have to look and see what the compiler's spitting out. But in 99.9% of cases, just let the compiler do what it's going to do, and you will... you'll be fine. So let's expect... We're going to expect the next thing is... a token concat, pass the error context down, and then we can skip it and grab the next one, and then we are going to... I don't know if that answered your question, by the way, if you want to clarify. I can also try to expand further, but... Okay, so if we see a concat, now we expect the next thing to be a parent open, which if it is, we can skip ahead. And then we need to do that same loop here. So let's take this whole loop out, actually. Good answer. With a follow as reward or punishment, however you will look at it. Thank you. Appreciate that. It's really dumb. As I've been streaming, I occasionally have had a decent number of people come in. I think it's because the programming I'm doing here is kind of niche, which is cool because it means people who come here tend to stick around because the kind of programming I'm doing is kind of unique on here. But I've totally done like call to actions like, hey, you should follow. And it totally works every time. And I feel gross every time I do it. So I appreciate the follow. Okay, we're going to have a function here called skip identifiers. Or skip identifier, how about just that? And we'll take the parser and the error context. We'll grab that too. Okay, this will just be the parser. This will be next, 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 whoa, next, parser, parser, parser. Okay, so if we get here, we are going to, if we see a concat token next, we need to call this recursively to skip past that, which is why I made a new function for this. Although, wait. No. Yes. Here. Okay. Here we need to still do this and then call us recursively in this case. That's what I was missing. So if we see a concat token, we can just call this. Otherwise, we keep looping. Maybe. I don't know. I've lost the plot a little bit here. We'll see where this takes us. So skip identifier on the peek ahead parser. And then the peek next will just be the next token in the peek ahead parser. Skip identifier. Too few arguments. Skip identifier. You are correct. Okay, let's just see where we're at now. That was a lot of code. Okay. All right. Peek token. This is going to be the right call. Okay. Next is std. We skip identifier, which should skip us all the way past. So what we're expecting this to do is to skip us past this, skip us past bro. Come on, bro. Skip us past that, skip us past the concat, and skip us past this. So we should be at the comma after all this is said and done. But instead, we trip a parsing error, so let's just see what's happening there. So next is std. It's a name, so we skip past it. Next is now concat, so we recurse in here. Next is concat. So we skip all the concat tokens, which means skip, skip. Oh, I didn't finish writing this. Duh. Right, I'm gonna have to forward declare this because C is a language that exists. And we will just call this a second time here. And then we expect now we expect a closing parent, at the very end. Okay, and we can skip past that. Okay, let's see where that got us. Skip this, skip identifier. We are once again std, advance. We're on concat, so we skip the identifier again. We see it's a concat, so we skip it. It should be a concat, skip it. Parent open, skip it. We skip identifiers again. So next here is arg. Oh, yes. Yes, so we're skipping, we're inside concat right now. So we advance, skip, nothing's done. Now we expect a closing paren, which we get. We skip past it, boom. So we skipped the concat tokens. We're good. So the next thing, forgot to say here, after we skip that, we have to do this again. So let's do that again. Skip the identifier, see the concat, skip those tokens. Okay, what did we do? I thought we just confirmed that that worked. Wait, what? What just happened? We are on std. Then we see a concat, so we skip identifier. No, we don't do that. Why are we loop? Wait. This loop is already doing that for us. We don't have to call skip identifier here at all. In fact, we just have to do this. We compiled. We didn't spit out valid code, but we are past the metaprogram. We didn't hit a parsing error. What did we spit out? I'm curious. If you're curious about what all this nonsense is, this is what. Okay. Oh wait, no, we're broken otherwise. I forgot about that, so that's fine. Hey, we actually spit out. Oh, no, we didn't. Never mind. We did not spit out anything valid yet. But we're closer. Oh, would you look at that? Okay, we're spitting out. This is an identifier, comma. This is an identifier, comma. This is an identifier. So I think we actually parsed that correctly, which means, let's close this and look at the tree. Let's look at the tree. I'm gonna spit it to a file because it's large. Okay, actually this one's not large. It's just, I stripped out all the other code. Here we go. Function call. Right. We pass it a decal ref called std. It doesn't know what that is. A function call to concat where we passed it out, which is also not right. Well, actually, that is correct. Actually, we passed it out in this case, so that actually is correct. Then another decal ref. So that might actually be right. That might be what we're expecting here. And then it'll be the codegen's job to put this back together. No way, did we actually do this? Did it happen? So now when we do parse function call, let's go there now, because that's where we go next. Parse function call. Just looked as GCC, we're after -e. God, I don't even know what -e is just off the top of my head in GCC. Oh, okay, it just shows, okay, gotcha. Okay. Grab token, function name is right, or it should be, yes. Okay. Okay, so even here, we should be able to concat that as well. I guess one thing at a time. And you know what? As we hit these, let's mark up the code to say to do should be able to concat function name. Okay, so let's go there. Create node. I have to recompile because my line numbers are off. Okay. So it's not a constructor. Create a decal ref for its name. We expect an open paren. We got it. Okay, parse call params. Okay. Advance. Parse the parameters. Here. So let's go there. Parse function call parameter. Parse call params. Here we go. So when we're parsing the parameters, we are going to say, if we see a comma, we just skip it. Otherwise, so this is calling parse expression, which should already be set up to handle concatenation, which is great for us. That means this should already be working, which is good news. Well, not fully working, but working to some extent. So parse call params. Next is the std. We should get an entire param node back that is... Oh, wait. Right. If we parse an expression that is a bunch of identifiers concatenated together, that needs to be updated to know what to do with it. Parse expression. Parse expression leaf is giving us right, okay. This is where this logic now needs to be updated to handle a bunch of names in a row for concatenation purposes. This is where it's going to get just a little bit tricky, but we're prepared for this. We got this. Nothing to worry about. So let's stop this. We are going to say parse expression leaf. So if we are in here, we've skipped ahead first to verify what it is we're parsing. If it's a function call, we'll worry about that later. We're not there yet. If it's not a function call, it's just a normal variable. This needs more logic to handle concatenated names. What happened to the first 10 streams? Are they not there? Did my VODs disappear? Let me look. Oh, maybe Twitch. Do you have to be like a Twitch partner or something to keep Twitch VODs? That's not a big deal. I'm streaming on YouTube also, and my streams go to a playlist on there. I can link it to you if you're curious. Here's the playlist on YouTube. And they're all there, and they will be forever as long as YouTube still exists. So cool. I appreciate that. Thanks a lot. Everything basically there from the video that's in my description for like what is metaprogramming, where I go over my system, basically everything from there till now I have streamed of this parser. Everything before that, where I actually just write the parser and the metaprogramming stuff, I didn't stream any of that, but that video on my channel goes over what my system looks like right now. But I really appreciate it. That's awesome. Okay. So this needs to be more robust. This needs to be result equals parse name. It's going to take the parser. I guess that's it. And we're going to say parse cast. We'll just put it down here, I guess. Parse name. I'm going to take the parser. So here's where all the real work is going to happen in here. And this should take the error context because we don't, this isn't giving us more context. Okay. So parse name. Let's make a note here for what this is doing. This assumes the next token is true according to is token is token is name. What did I call this? Token is name. Returns a ooh, wait a minute. Right now I'm returning a decal ref. Yes. Right now I'm returning a decal ref, which is one of these. This needs to be changed to this. Oh, I already added the things here. I need to fill this out. So, as soon as it returns a this is going to be each through identifiers, returning a This should return one of these things. I'm overthinking this. This needs to return an identifier node. Straight up. And it's going to have, it will be a linked list of partial identifiers is what it'll be. At which point we can just stick it onto, in this case, the decal ref, but it's anything that we have. So each identifier is returning a linked list of partial identifiers, which then you can, whatever, I'll just call it that, that's fine. That's descriptive enough. So we're going to continue doing what we were, excuse me. We're going to continue doing what we were doing here, and parse name, not do this, we're going to do this, but instead of next here, we're going to say identifier node equals parse name, parser error context, and we're just going to pass it this name. So create decal ref node. For now, I'm going to replace, or I'm just going to have a copy of this because I don't want to break the rest of the parsing right now. Name. Create the decal ref. I need the line number, which will be name. How about we pass it the line? Which means parse name. This needs to be next line. Okay. The result is a node. Its name is now not just getting the text, it's going to be name. Right? Yes. Looks good to me. And we don't have to advance the line or advance the token anymore. That's going to do that for us. Okay. Now we just need to fill that out. 1139 decal name equals name. Oh, right. Decal identifier. This is decal identifier. Okay. Well, we're still failing. Hold on. I thought we got past this. Right. Need to fill out this function now. So, we are going to say we have one of these, which is the result. And we'll return result. Now, at this point, we can be certain that we just have a bunch of identifiers in front of us, or a bunch of names in front of us. So we should be able to just say Next is peak token parser while next, and next type is and token is name next. Okay, great. We are going to say if next type is token concat, else, so if it's not a concatenation, we can just do what we've always been doing and just say that result dot, what did we call it? Result dot text is just equal to get token text of next, right? Although that's just for the first one. So actually what we need to do is say okay, here's what we're gonna do. Output is, or we'll say target is result. We'll say while target and target next, target equals target next. So we're gonna go to the end of the linked list. That could either be the result itself or its next one if it has a next one. This is going to be target. Okay, and then advanced token parser. Next is peak token parser. So, this is still not going to do what we want it to do, actually. We need... I'm trying to think, because what happens right now is we will go to the end until we're at the very last node. And then we can fill that in, but then we have to give it a next one. Right. Okay, so if we hit the end, we know it doesn't have a next. So all I have to do is say target next is push type parser arena, and we're going to push onto it another identifier node. Okay, I think that's all we have to do. So and actually this can go in here. I mean, that is super lazy, inefficient. Because otherwise we'd be saying, as long as the next thing is something we have to append, we'll do that at the end anyway. Let's do that. If we get to the end, if there's something to append and we do it, then we can do this. I think that's fine. Yes, and target will equal target next. Yes, okay, that's fine. So, assuming we don't have any concat nodes in here, which let's just turn that off for now, this should actually work just fine. Token is name? What? Of course, this has to go up here because C. Where are my other helpers? We'll just put it here. Why not? Okay. We do not have a parse error anymore. But we did not spit out good code. So I already know that's broken. But so that's broken too. What about this? Yes. Oh, but we're just not spitting out. Okay, hold on. We might actually be back in business if I fix codegen now to say append node as string or get node as no, append node as string. And if we see, oh, we need a helper function here to reconstruct a name from an identifier node. Right, because we know we aren't going to be having this name on here anymore. So we need a helper that's like we're going to need like construct node name. And this can actually just be a short string. We'll just build it right here. It's going to take the node and that's it, I think. And we can just say node is node identifier. Although wait, I want this to work no matter what I pass to it, so we're actually going to do a switch case on the type. And we're going to say if we hit the default case, this is a parse error or report error and exit. Actually, no, this should be an assert false. We should never hit this. This should never happen. This should never happen. Constructing, trying to construct node name. Oops. Construct node name from an invalid node type. You know what? Let's just print this whole message and actually format it. This is Lexer. Do I have a helper for this? I don't even know. Yeah, I do. Oh, I have print node nicely, but I don't have. Okay, you know what? Parser node type strings. And this is node type. Okay, so we have a couple different cases here. We can construct a node name in these cases. Identifier node. We can do it in any of these cases. We can do it in any of these cases. We can do it in these cases. We can also do it in, you know what, these actually don't need to be separated because they're all the same name. These cases, this is its own, so let's remove this. This is its own, and we're gonna say AST decal type def and decal ref and keyword. So keyword can go up here. Is it just keyword? No. Expression keyword? Yes. A cast as well. That's it. And we're gonna say type def. All right, here's what we're gonna do. We're gonna say boom. Wait, hold on. Let's redo this. We're gonna say starting from here, we're gonna go down, set the mark, up, boom, 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 boom. Search for case. Boom. Boom. Boom, 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 boom. Case. Oh, I can't return to the mark. That's fine. I'll go up here. Go down. Boom. Didn't work at all. I try to get fancy, and it doesn't always work. Yes. Doing macros is always a fun time until they don't work, and then you're sad. Let's try that one more time. So, do we have... Yes. We're gonna grab this, look for case, boom. We're gonna do less copy pasting. Oh, I actually did it that time. I just forgot a forward parent. I messed that up that time. Okay, this is the last time I try this. Now I'm actually wasting time. So we are gonna go here. Grab this case. Boom, 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 boom. Case. Boom, 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 boom. Boom, boom, boom. Okay. I don't know why that's not working now. I give up. It's fine. At this point, it would be much faster to do it this way anyway. Let's grab this and put this up here too. And then we will do this. Oh. That would have been much faster in the first place. I was trying to be very fancy with it, and there was no reason to. Okay, so those are all those. This is just a type def, and we're gonna say to do could be oh, function is like that too, actually. Function needs its own. We'll come back to that. Could be alias or base type identifier. So we'll just say assert false for now. We just don't handle this yet. So sucks to be you if that doesn't work. We'll say the same thing for functions, because it could be the return type. It could be the name or the return type. Okay. Struct, it can't be. We'll just do this. Identifier. So that has two of them. It could be. Type def does as well. Okay, we're good. So decal ref, we're saying gonna do this. We're gonna put these on all of these that we're not having done yet. Okay, so decal ref is what we're doing right now, which is decal identifier. So construct the node name from that. So we are going to actually, these are going to be handled. This is all being handled in one fell swoop, because all we're doing here is setting this pointer. That's all we're doing here. So node is oh, nope. Okay, it doesn't actually matter that these are named the same thing. I forgot how my system works. That's how long it's been since I've been doing this. And by that I just mean a couple weeks. These are all their own. This is like a, what do you call it? Like a, wow, I'm blanking on the name. But like a union, that's not really a union, but it's like a single struct that's discriminated union, I think is the word I'm looking for. So I have to determine that here. So not function, constructor, destructor, implicit template, boom. This is all their own. Struct and struct template is their own. Union is its own. Enum and bitfield are their own. Keyword is its own. Okay. So if it's this, node will equal node info dot decal variable identifier, and this will be a pointer. If it's this, it will be decal struct, or decal function rather. No, Yeah, decal function. Oh. Constructor, destructor, those don't have return types. Struct function. Conversion. This actually goes with this. Yes, this goes with function template, or with decal function. These, I don't remember what I used decal struct function for. Decal struct, that's not a great name. That's if it's a struct member who is itself a function, like a function pointer or something. So that does have a return type, I think, in my tree, in which case this also has to go down here. Okay. That's fine. This will be the struct decal, or no, decal struct rather. This is decal function. Decal union. Decal enum. Expr keyword. This is expr cast. Come back to this, and this is expr decal ref decal identifier. Okay. Cool. Then if we hit something we don't understand, we will assert here, which should never happen. Declaration of node shadows a parameter. You are correct. We're passing it a node. This is not, we're gonna call this identifier. Okay, great. Expr decal ref, oops. Default needs a thing. Okay, great. So where are we now? Assert message. Why don't you like that? Oh, because message is not a short string. It is... Right, this is stupid. Message, C message. Look at that, we're back. Okay, so. Result should be nothing right now, but let's just see if we write output. Let's just do this. While identifier, we'll say identifier equals identifier next. So we're going to loop over all of the identifiers in this, all the partial identifiers in this linked list. We'll say if identifier, what did I call it? Node. Otherwise, result plus equals text. Otherwise, result plus equals what would it be in this case? It would be well, I guess it depends on what kind of node it is. get identifier string from identifier node. And this is going to be get identifier string from. It's going to take one of these nodes. And it'll be another switch on the node's type. So, do I have a concatenation node? Is that a thing in here now? Wait a minute. There aren't any concat nodes on the tree. They are just... Wait. I'm confusing myself now. At this point, we're looking at one of these, which means the thing we're pointing to is not just text. It's a node that needs resolved to an identifier. Or no, that needs resolved to some text of some kind. So it's either straight text or a parser node, such as a parsed expression from inside a concat directive is what I wrote here. Are we even at the part where I'm doing this? Oh yeah, this is in codegen. Never mind, I am here. Okay, we're in codegen. We're not in the parser. So, so I need this to be... Why is this confusing me so much? So if I get here, let's compile this. Whoa, what did I do? 20. Oh, that's the thing. Oh, so we are hitting this now. There's a good sign. I think, unless the the compiler's catching that for me. That's actually not. That's nothing to write home about. No return statement. You are right. Okay, let's see what this is doing. Where's codegen? I passed it. Okay, let's remove this. Let's go to construct name. Let's do that. We're never even getting there. Cool. Am I calling this? No, it would help to call it. Where was I writing this right? Oh, yes. Okay. Let's go to declref because that's what we're doing right now. Here. So instead of the name here, we are going to say shortstring name is construct node name of node, and we're just gonna append the name. What do we get? Let's see what we get. See, now we hit it. Let's jump out and just see what we got for name. A bunch of nothing. That's expected, I think. So the node here that we're looking at. Node is a decal ref whose children are nothing, but whose info is right. Okay, we're not actually there yet. Hold on. What is its identifier? Decal identifier is nothing. Although for right, it should be. Wait, decal name is set right? How is decal name set correctly? That means we're... Oh, because we're calling it with the old one. The old one is still working. That's why. Create decal ref node. Function name right here. Here's where we do parse function call. We should be able to do this here and replace this. This is kind of a tangent, but also not, because it's directly relevant to what we're doing. This should be able to be changed to identifier and okay, this actually got a little complicated again because if we grab what we think is the name and the name turns out to be a type, we know this is a constructor. We're calling a constructor. We're not calling a normal function. But we can only know that after we Yeah, this is... I think I'm now finding myself at odds with two different things in this case. One is parse time, like in the tree, concatenating things. So we can construct the tree correctly. And the other is at codegen time. This is something that needs concatenated at parse time, actually. Because if you're concatenating something here that will turn into a known type, we have to be able to do that right here. We can't wait until codegen. Well, I guess we technically could, because in codegen we do this post pass on the AST. It's the first thing that happens before the metaprogram gets a hold of it to like fix up some stuff. One of the things we could fix up is just look at all function calls, and if their name resolves to a type, then update it to a constructor call at that point. We could do that. And then all the parser has to know is that this is a function call. I don't care what kind of function call it is. It's just a function call. Which I don't love because it's making the parser dumber. It's making the tree that comes out of the parser more incomplete. So I don't like that. Yeah, now I'm at a little bit of a crossroads here because by the time we're parsing this, although wait a minute. All we're parsing at this point is this right here. Yeah, but this could be concatenated, right? You might be able to say like type and be able to say like I don't know. Right? Like whatever you want to do there to concatenate a name together there. So this has to work. Yeah, that's a little tricky. This might take some offline brain power to think through. It doesn't help that it's almost 11 o'clock. And I did start kind of late tonight, unfortunately, but I think I need to think through what is known that can be concatenated at, I'll just call it parse time rather, and codegen time. Those are two different things. Thank you, I appreciate that, and I appreciate the follow. And I appreciate you continuing to watch and listen to me when it feels like I'm saying nonsense, but hopefully you're following along. You kind of know what's happening if you are like actively paying attention, which I wouldn't blame you if you weren't. It's inspiring. Well, that's awesome. I hope so. I've been inspired by so many programmers that I've watched online, and it's the only reason I really decided to stream this, because those people inspired me. So that's awesome. Yeah, but I think this is going to take some offline brain power. I am happy with the progress I've made though, because now I'm actually parsing this line properly. Like we're not just breaking immediately on that part, so I'll take that as a win. I should do more work and be less on Twitch. Dude, trust me, I know that exact feeling. You are not alone. I almost didn't stream tonight and instead was gonna watch someone else program, so I literally know the exact feeling. But then by watching them program, it made me want to come up here and program. So sometimes it just be that way sometimes. More progress still left in a broken state. And actually, before I push this, I'm gonna give myself a more up-to-date to-do here. August. We're passing the parsing stage now. However, we may have to now think way more concretely about what it means to concat at parse time versus codegen time. During parse time, we have an incomplete view of the code, an incomplete tree with no connected decal refs, which means certain information like is known type on a function call name seem at first glance unresolvable. However, at codegen time, we know things will be linked up properly and can replace the concat text with the proper thing. See where we left off in, where are we? Where we left off. Parse function call. Okay. More progress. Still left in a broken state. C new to do in Linux main DB. Okay. More progress on parsing multiple partial identifiers for concatenation. Okay. Well, yeah, like I said, thanks so much for watching. I really enjoy streaming this stuff. It's been super fun and keeping me on track. So I definitely hope to see you around some more. Thanks again for the follow. And yeah, I'm curious to hear your updates if you continue working on stuff. I like hearing about what other people are doing. So yeah, thanks so much. And yeah, have a good night if it's nighttime for you. Otherwise, have a good day. And yeah, I will see you later. Thanks for watching.